Imagine a computer so powerful it could solve problems in minutes that would take today's fastest supercomputers thousands of years. This isn't the stuff of science fiction, but the promise of quantum computing. Now, you might be thinking, what exactly is quantum computing? Well, let's dive in. Quantum computing at its core is a new type of computation that leverages the principles of quantum mechanics. Now, if you've ever tried to wrap your head around quantum mechanics, you'll know it's famously complex. But don't worry, we're going to keep things simple. Picture classical computing, the kind of computing we're all familiar with, like searching for a book in a vast library. You'd start at one end and work your way through, book by book, until you find what you're looking for. This process, while reliable, can be time-consuming. Now, imagine if instead of checking each book one by one, you could somehow check all the books at once. That's the magic of quantum computing. It's like being able to read every book in the library simultaneously. This ability to process vast amounts of information all at once gives quantum computers their potential for incredible speed and power. But how does this work? Well, while classical computers use bits as their smallest unit of information, each bit representing either a 1 or a 0, quantum computers use quantum bits or qubits. These qubits, thanks to the quirks of quantum mechanics, can represent a 1, a 0, or both at the same time. This property, known as superposition, allows quantum computers to process a massive number of possibilities all at once. So there you have it, quantum computing in a nutshell. A revolutionary approach to computation that could redefine what's possible in fields, from medicine to cryptography. But as with all great leaps forward, there are challenges to overcome and mysteries to unravel, and that's where the real adventure begins. While classical computers use bits as their smallest unit of information, quantum computers use quantum bits or qubits. What if a coin could exist in a state of being both heads and tails at the same time? Welcome to the quantum computing realm. It's time to go beyond the surface and dive deeper into this mysterious world qubits rule. Qubits are the foundational units of quantum computing, defying the norms of classical computing set by bits. Unlike bits, which can exist in one of two states, 1 or 0, on or off, qubits bask in the phenomenon of superposition, enabling them to exist in multiple positions simultaneously. This remarkable property amplifies the data processing capacity of quantum computers. Let's draw a comparison with the world of classical computing. Bits are rigid in their existence, only being 1 or 0 at a time. However, in the contrasting quantum world, a qubit can exist as 0, 1, or an amalgamation of both. This powerful capability is the driving force behind the superior computing power of quantum computers. It's as if you have a turbocharged engine powering your computer. Now, doesn't that revolutionize the game? Ever heard of two particles behaving like Siamese twins, mirroring each other's state no matter the distance between them? Welcome to quantum entanglement. Quantum entanglement, despite its seemingly magical nature, is a fundamental principle in the quantum world. To help you grasp this concept, let's use the analogy of Siamese twins. Imagine two twins linked in such a way that if one feels joy or pain, the other one does too, irrespective of the distance between them. They could be in the same room or on opposite ends of the universe. The effect remains the same. Now, replace these twins with subatomic particles, and you've got quantum entanglement. When two particles become entangled, the state of one instantly influences the state of the other, no matter how far apart they may be. This isn't some kind of cosmic telepathy though, it's a deeply rooted feature of quantum mechanics. And here's where it gets interesting for quantum computing. In a classical computer, information is stored in bits, which are either in a state of 1 or 0. But in a quantum computer, we deal with quantum bits or qubits. Thanks to entanglement, a pair of entangled qubits can exist in a state where they are both 0 and 1 at the same time until measured. This allows quantum computers to process vast amounts of information at once, making them incredibly powerful. However, don't be fooled into thinking quantum entanglement is all about speed. It's also about creating new ways to move and store information. For instance, quantum encryption uses entanglement to create unbreakable codes, offering a whole new level of security. So while quantum entanglement might sound like something out of a science fiction movie, it's an integral part of the quantum realm and the future of computing. This spooky action at a distance is another key principle that sets quantum computing apart. What if we could design more effective drugs, optimize complex systems, or crack the most secure codes? These are just some of the possibilities with quantum computing. Let's take a closer look at these. With quantum computing, we could revolutionize the field of medicine. By simulating how different molecules interact, we could potentially discover new drugs and therapies much faster than we can now. Imagine being able to tackle diseases from a whole new angle, creating treatments tailored to an individual's unique genetic makeup. This is personalized medicine at a level we've never seen before. Next, consider optimization problems. These are everywhere in our world, from determining the most efficient routes for delivery trucks to figuring out the best way to allocate resources in large organizations. With the power of quantum computing, we could take on much larger and more complex optimization problems than ever before. It's like having a supercharged GPS that can figure out the best way to get everywhere, all at once. Then there's cryptography. Right now, our most secure codes rely on the difficulty of factoring large numbers into primes, a task that's easy for a quantum computer. This might sound like a security nightmare, and in some ways it is. But it also opens up the possibility of quantum cryptography, a way of encoding messages that is potentially unbreakable. But it's not just these fields that could be transformed. From climate modeling to financial forecasting, the potential applications of quantum computing are vast and varied. This isn't just about doing what we already do, but faster. It's about tackling problems that are currently beyond our reach. The potential of quantum computing is enormous and could revolutionize various fields. It's a whole new way of looking at the world, a key to doors we didn't even know were there. So let's step forward into this quantum future, curious to see what we might discover next. The potential of quantum computing is enormous and could revolutionize various fields. Quantum computing sounds like a dream, doesn't it? But like all dreams, making it a reality isn't without its challenges. You see, the world of quantum computing is just as complex as it is fascinating. One of the greatest challenges we face in this field is maintaining qubits in a quantum state, a phenomenon known as decoherence. Imagine a spinning top. It starts off stable, but over time, it wobbles and eventually falls. In the same way, qubits can only maintain their quantum state for a short period before they lose their superposition and entanglement. This makes long computations difficult and error-prone. Now you might be wondering, why can't we just keep them in a quantum state for longer? Well, that's where another challenge comes in. Qubits are incredibly sensitive to their environment. Any form of interference from temperature, electromagnetic fields, or even cosmic rays can cause them to decohere. To prevent this, quantum computers are kept at extremely low temperatures, colder than outer space, in fact. It's a bit like trying to keep a snowflake intact in the Sahara, but with a lot more science involved. Not only that, but building and maintaining such systems is difficult and costly. It requires expertise in various fields, from quantum physics to materials science and engineering. And even then, we're still in the early stages of understanding how to best design and scale these systems. Moreover, we face a challenge in terms of algorithms. Classical algorithms won't work on quantum computers, so we need to develop entirely new ones. This requires a whole new way of thinking about computation and problem solving. But don't be disheartened. These challenges are simply hurdles we have to overcome in the pursuit of technological advancement. They might be high, they might be tough, but they're not insurmountable. Despite these challenges, the future of quantum computing looks bright and promises to change the landscape of technology as we know it. As we've seen, the world of quantum computing is filled with challenges. Yet these are not roadblocks, but stepping stones to a future where the unimaginable becomes reality. The potential of quantum computing is immense. It promises to revolutionize fields like cryptography, material science, medicine, and more. Imagine designing new materials at the atomic level or simulating complex biological processes to develop new drugs. These are just a few of the exciting possibilities that lie ahead. And while the challenges may seem daunting, they are not insurmountable. The scientific community is hard at work, making strides in quantum error correction, developing new algorithms, and creating more stable qubits. So what does this mean for you and me? A future where quantum computing is commonplace may still be some time away, but its impact is already being felt. From secure communications to advanced simulations, the benefits of quantum computing are slowly but surely trickling down into our everyday lives. And as we continue to push the boundaries of what's possible, who knows what exciting new developments lie just around the corner? There's no doubt that the journey to quantum supremacy is a challenging one, but it's a journey that's well worth the effort. So, as we stand on the brink of this new era in computing, let's embrace the challenges and look forward to the future with anticipation and excitement. The world of quantum computing is not just a dream, it's a reality that's unfolding right before our eyes. So stay tuned and join us on this exciting journey into the quantum realm. And remember, the best way to predict the future is to create it. So, let's create a future filled with quantum possibilities. Don't forget to like, comment, and subscribe if you enjoyed this video on quantum computing. Stay tuned for more exciting content.